Alright, in this video we're going to look at a whole bunch of examples where we are using the laws of logarithms to either expand or combine logarithmic expressions, right? In the first few examples up here we're being asked to expand, right? So we want to expand these expressions as much as possible using those three laws of logarithms, which if you did not watch the video that I did on the three laws of logarithms where I explained what those three laws are and how they work, you should definitely check out that video before you watch this one, because here we're just going to use those laws, not really explain what they are. Right, so the first example, log base 2 of 6x. Right, so the first thing is identifying which of the three laws I need to use. Well, here my logarithm involves multiplication, right? 6 times x, and that's that first law of logarithms that we talked about on that other video. Right, and that law of logarithms says if I have a logarithm of something being multiplied, I can break that apart. I can expand it into two separate logarithms that are being added together. Right, so it's log base 2 of 6 plus log base 2 of x. That's what log base 2 of 6x is equal to. Right, so that's a pretty straightforward application of that first law of logarithms. I have a log of something being multiplied. I split it apart, two different logs. They both keep the same base. Right, if this was base 2, the 2 I separated into keep that base of 2, and then I take the 6 and the x and put one of those in each of those separate logs with addition in between them. All right, so that's using that first law of logarithms. The second example, log base 5 of x to the third y to the sixth. Well, this one's going to involve a couple of those laws of logarithms. The first one, though, just like example A up here, I have multiplication, right? I have x to the third power times y to the sixth power. So the first thing I'm going to do here is separate this into addition. So it's going to be log base 5 of x to the third plus log base 5 of y to the sixth power. All right, so identify here that I have multiplication, or just like up here, the 6 times x. Here I had the x to the third times the y to the sixth. So the first law of logarithms tells me if I have multiplication there, I separate it into addition. Same base, so a base 5, each of those keeps that base 5. And then I take the two things multiplied, x to the third and y to the sixth. Those go in the two separate logarithms. Right, but now there's more I can do. Right, since the things inside my logarithms here are being raised to powers, I can use that third law of logarithms that we talked about on the other video, which says if I have a log of something raised to a power, I can bring that power out into the front. All right, so this is going to be 3 times log base 5 of x plus 6 times log base 5 of y. And now I have expanded that logarithmic expression completely. All right, that's everything I can do to simplify this or to expand it as much as possible. All right, so in this case, when we have things being multiplied but also being raised to a power, since the x to the third is multiplying the y to the sixth, right, to kind of undo all that stuff, we have to undo the multiplying first, get the x to the third separate from the y to the sixth, and then we can take each of those exponents and move them down. Right, I wouldn't start here by trying to bring the 3 out to the front, because I also have that exponent of 6 in there. Right, they don't have a common exponent. So I separate them first, and then I bring each exponent down individually into each separate logarithm. All right, so that's combining laws 1 and 2. And now for example C down here, we're actually going to have to use all three of the laws of logarithms. So this one's going to be pretty fun. First off, ln, right? Hopefully you watched the other videos that I did about logarithms. Ln represents the natural logarithm. It's a logarithm with base e. But remember, for the natural logarithm, all of the rules, all the properties, all the laws of logarithms apply. It's just like any other logarithm. It just gets a special name, ln, because that base e is so special and it's used so often. Right, but I still use the same properties that I did, whether it's an ln or a log base 5 or any other base. All right, so ln of ab over the cube root of c. All right, so first thing I see here, I have that division. Right, I have ab divided by the cube root of c. That's law number 2. Right, law number 2 says if I have the log of something being divided, I separate that into two different logs. So it's going to be ln of ab, my numerator, minus ln of the cube root of c, which is my denominator. Right, so law number 2 says when I have division inside my logarithm, I split it up into subtraction. All right, and since this is a natural log with base e, the 2 I split it into also natural logs with base e. All right, then I can split up this first one even further, right? Because this first ln has multiplication here. That's a times b. So that's kind of like these first couple examples that we did. All right, so that first one is going to become ln of a plus ln of b. All right, so I can split apart that one that involves the multiplication. So that's law number 1, right? Multiplication tells me to split it apart using addition. And then this one here, is there anything I can do with that cube root of c? Well, there is, if you remember that the cube root, or any root, can be changed into an exponent. And I'm just going to write this up above and make a note of it here. Right, the cube root of c, right, the third root of c, is c to the 1/3 power. Right, that's what the cube root of c is equal to in exponential form. So really this is going to be minus the natural log of c to the 1/3 power. And since I have that c being raised to a power, kind of like what I did here in the second example, that exponent can be moved out to the front of the logarithm. So that's going to be minus 1/3 times the natural log of c. Right, so for that one example there, we actually had to use all three of the rules, right? First we used, or all three of the laws, I should say. Right, first we used law number 2 to separate that division into subtraction. Then I used law number 1 to separate, in this first one here, the multiplication into addition. And then I also used law number 3 to take the exponent of here, that 1/3 power, and move it out to the front. All right, so that is expanding this logarithm here completely. All right, so 3 examples there of using the laws to expand expressions, break them apart into separate logarithms. I'm going to pause the recording here and erase all these examples, and then I'll put up some examples where we go the other way, where we start with something that looks like this, and we have to combine it all together to get an answer that looks like that. All right, so hang on for a second. All right, we have some examples up here now where we are asked to combine logarithmic expressions. So we have to take these expressions that we have and put them all together to just one single logarithm. And we'll have a whole bunch of stuff involved in that logarithm. Right, so the first one here, 3 log of x plus 1/2 log of x plus 1. Right, so first off, before we can use the laws of logarithms to combine logarithmic expressions, we have to double check that they have the same base. Right, I cannot use laws numbers 1 and 2 unless the logarithms have the same base. Well, in this case, they both have a log without a number in the subscript. So hopefully you recall that a log that doesn't have the number in the subscript is what we call the common logarithm, which means that the base is 10. All right, so since both of these are the common log, they're both base 10, which means we can proceed to actually combine these together. Right, if this was a base 5 and this was a base 3, there wouldn't be very much we could do here to try to combine those. All right, so first thing, when you're using the laws of logarithms to combine expressions, the first thing you always have to do is take any numbers in front, like the 3 and the 1/2, and move them into the exponents. Right? I can only use laws numbers 1 and 2 if there's no numbers in front of the logarithms. Right? Those only work if it's just a log plus a log or a log minus a log. It doesn't work if there's a 3 log plus a 1/2 log. Right? So I always have to use, when I'm combining logarithms, I always use law number 3 first if I'm able to. All right, so this is going to become the log of x to the 3rd plus the log of x plus 1 to the 1/2. All right, so the 3 goes into the exponent of the x, the 1/2 goes to the exponent of this entire parentheses, x plus 1. Right, everything that's inside that parentheses is going to get raised to that 1/2 power. Right, so once I do that, now I have just a log plus just another log. So now it's one of 2 options. If there's a plus here, I use law number 1. If there's a minus, I use law number 2. Right, doing these problems is not super difficult as long as you remember what those laws say to do. Right, as long as you do the third law first. So exponent moved up, and then is it a plus or a minus? Right, if it's a plus, like it is here, I combine these into a single log. Right, they were both log base 10, so I keep it a log base 10, a common logarithm. That base doesn't change when I'm using these laws of logarithms. So it's going to be log of, and then I multiply the x to the 3rd times the x plus 1 to the 1/2. X to the 3rd times x plus 1 to the 1/2, and that's it. Right? When I have addition, that tells me to take these 2 arguments here and multiply them together. Right? The other option was, if that was subtraction, I would take the 2 and divide them, put them into a fraction. Right? That's basically it as far as combining logarithmic expressions. Numbers in front move to the exponent, and then you either multiply if there's addition or you divide if you have subtraction. That's it. All right, so that's our combined form of this original expression that we had up here. And again, we have to do that sometimes when we're solving logarithmic equations. If it was this equals 5, well, before I can solve that equation, I have to do all this work to combine this into a single log equal to 5, and then I can go through my steps to actually solve the equation, which is something that I'll talk about on another video that I'll be doing very soon. All right, the next one here, 3 ln s plus 1/2 ln of t minus 4 ln of t squared plus 1. All right, so once again, if I want to combine all these together, first thing I have to do is clear out any coefficients, any numbers in front, move those into the exponents. So the 3, the 1/2, and the 4 all got to get moved. So it's going to be ln of s to the third plus ln of t to the 1/2, and then minus ln of t squared plus 1 to the fourth. All right, now sometimes there's a question here that students have, well, it's a minus 4 here, so should I move the negative 4 into the exponent, or should I just leave the negative and move the 4? And you could do it either way. My advice is to leave the minus there and just move the 4. It's just going to make it easier to do the next step if we do that. All right, so if you have a negative exponent, then you have to remember to make this a plus and make that a negative 4, and then you have to do the rules of negative exponents at the end to simplify it. So it's easier to just leave the minus there and just put the 4 up top. Right, that's my advice for doing something like that. All right, so I took all my coefficients, all my numbers out front, moved each one into the exponent of my argument of my logarithm, and now I need to combine them together. So the first two here, ln of s to the third plus ln of t to the 1/2, well, there's addition, which means I need to multiply this s to the third and the t to the 1/2. All right, at this point, I'm just going to do one thing at a time. So ln of s to the third t to the 1/2, and then still minus this ln of t squared plus 1 to the fourth power. All right, so I just, the first two that I see, I put those together. Since that's addition, I multiply, and now I have two logarithms that are being subtracted. And I didn't point this out, but all three of these are the natural logarithm, right? They're the log with base e, which means I am allowed to actually go ahead and combine those together. All right, so that's what I'm doing, right? You should really check that out before you start using laws numbers 1 and 2 to combine them, right? So I use law number 1, I get this, and now I have subtraction of two logarithms. All right, so what I need to do then is use law number 2, which says when I'm subtracting two logarithms, that leads me into division, right? So this is, and I hope you're all able to see this. Let me actually erase some of this up here so I can put up the answer and make sure it's clear for you to see. Right, so this is going to equal the natural log of the first one, s to the third, t to the 1/2, over the second one, which is t squared plus 1 to the fourth power. All right, and there's my combined form of that original logarithmic expression that we've got there. All right, so that's combining logarithms. For this one, we had to use all three of the laws, right? We had to use law number 3 first to take those numbers in front, move them into the exponents. To combine the first two, I'd use law number 1. Addition leads me to multiplication. To combine that with the last one, since there was subtraction, I had to use law number 2. Subtraction leads me into division, right? And when you're doing that, changing subtraction to the division, whatever is in that first logarithm goes in your numerator, the top of your fraction. Whatever's in that second fraction, the one that's being subtracted, that's the one that goes in your denominator, right? And just on a side note, I mentioned before, like when we took that negative 4 and I left the negative here and I moved the 4 up, if you had moved the negative with the 4, you would have had a plus here and a negative 4, which would have meant you would have multiplied this t squared plus 1 to the negative fourth power. But then that negative exponent tells you to put it in the denominator, so you still end up with what we would have had here. It just would have been like an extra step of work to do, which is why I advise you to just leave this negative and just put the 4 up top. All right, so that's, again, my advice on what to do when you have negative numbers in front of your logarithms. All right, so that's a whole bunch of examples where we first split apart logarithms and then combine them together using those 3 laws of logarithms. And there's only those 3 laws of logarithms. So once you know those 3, you know how to deal with logarithms. That's pretty much it. The only thing that can make it more difficult is putting, more and more terms in here, and that doesn't make it more difficult. It just makes it more work to do to combine it together, right? But once you know what those laws are, you're all set on problems like this.